So Patriots, in this video what we're going to talk about are three theorems called the tangent-tangent theorem, the tangent-secant power theorem, and the secant-secant power theorem, and the properties of those. What we're going to be doing is we're going to be drawing tangent segments and secant segments from the same point to the same circle and seeing what happens with those. So our first one is the easiest one. If we have two tangents drawn to the same circle, and you can see right here that we do have two tangents. This is a tangent and this is a tangent because they each touch the circle once. The rule says if I give you those two tangent segments, they have to be equal to each other. These two tangent segments are going to be congruent. They will be the same length. The length of EC equals the length of EB. So that is our tangent-tangent theorem. The lengths of two tangent segments drawn to the same circle from the same point are always congruent. So what it looks like if I give you numbers, I have a tangent segment right here. It goes from O to G. It touches the circle once. This segment goes again from O to E. It touches the same circle once. We know yellow and yellow have to be equal to each other. So the length of segment OE is going to equal the length of segment OG. And if OG is 11, that means OE has to be 11 as well. Boom. Well, what if we do it with secants? Well, the rule with secants, I'm going to type this out so it looks a little nicer. I tried earlier with the video to draw it by hand and it didn't work. What we are going to do with our secants, the rules are a little confusing, but what we are going to do is we're going to take the length of the outside and we're going to multiply it by the length of the whole secant segment, and that is going to equal the length of the outside of the other secant times the length of the whole part of the second secant. Because the rule says if I draw two secants from the same point to the same circle, the external part, the outside part, times the entire segment, secant segment, will equal the other outside part times the whole thing. What that looks like, what that's going to look like is we're going to take the outside part of 1 and we are going to multiply it by the whole thing of that same segment. And we'll multiply that by the outside part of the second one, and multiply that by the whole part of the second one. So when I do yellow times green, that will equal blue times purple or pink, however it's coming across on your screen. So let's take a look at that. The yellow segment is AN. The green segment is the entire length, AG, and that will equal the outside part of the second one, AE, times the whole length of the second one, AL. Boom. So outside times whole thing, AN times AG, will equal outside of the second secant, AE, times the whole length of the second secant, AL. So when I look at that in numbers, when we are looking at numbers, so if I do yellow times green, that's going to equal outside blue times whole thing, which is purple. Now pay attention to how we have to do this. So I'm going to put these boom, boom. Alrighty, so yellow is 4 long. Well, how long is the green segment? How long is this whole segment right here? Well, it's 4 plus 5, which is 9. Then blue is 3. And pink or purple, depending on how it looks on your screen, is 3 plus 9, which is 12. So 4 times 9 is 36. 3 times 12 is also 36. Boom. We can also take a secant and a tangent and do them together. And it's basically the secant power theorem all over again. What we're going to do is we're going to take the length of the outside. We are going to multiply it by the length of the whole thing. and then we're going to take the length of the tangent on the outside, and we'll multiply it by the length of the whole thing. We're going to square the tangent. We're going to multiply the tangent by itself, because it's kind of hard. We really can't do it because it's the same part. So I guess we can, but it's the same segment length. So I like to think about it just like the secant. Outside times whole equals outside times whole. We're going to do outside times whole equals outside times whole. So that's going to be JU times JM. And that equals outside of the tangent is JP. Well, the whole tangent length is again JP because all the tangent is outside the circle. And if we look at it with numbers, I have a secant. You can see here, I've got a secant on top and a tangent on bottom. So we're going to do outside whole, outside times whole, yellow times green equals blue times purple. Boom, boom. Multiply those, make it equal to blue times purple. So I'm going to do 4. Now the whole thing is 9 because 4 plus 5 is on the inside, is 9. Outside times whole equals outside times whole. And on a tangent, they're the same. So 4 times 9 is 36. 6 times 6 is also 36. Boom. Not so bad. So 3 rules that basically all do the same thing. The tangent, they just equal themselves. But the other ones, we're going to go outside times whole equals outside times whole. So if you still got some questions, jot them down. Make sure that you come in and ask them of your teacher. And Patriots, we will see you when we see you, and we wish you the best.